Hello and welcome to Digital Signal Processing. In this video, I'll show how to write MATLAB code for cross and autocorrelation of the signals. Before going to the programming section, first let me explain what is correlation and what is cross correlation and autocorrelation. And later I'll give an example how to find auto and cross correlation. Then we'll go for the programming section. So correlation, we all know what is called correlation in digital signal processing. Correlation always describes mutual relationship between the signals. That is, it indicates the measure up to which a given signal resembles the other. So depending on the signals considered that are same or different, we have two types of correlation. One is autocorrelation and other one is called cross correlation. Autocorrelation is if a signal is correlated with itself, usually time-shifted version of itself, then it is called autocorrelation. Whereas cross-correlation is correlation of a signal with another signal so as to know how resemblance exists between them. So that is a signal with itself is called autocorrelation. Signal with other signal correlation is called cross-correlation. So that is the difference between auto and cross. First, we'll consider the autocorrelation. So to find the autocorrelation, we have to consider a signal. Suppose consider a signal x of n is equal to, suppose this is a signal consisting of the samples 1, 2, 3, and 4. We want to find the correlation of the signals. So autocorrelation, according to the definition, we have to find the correlation of a signal with itself with time shifted version. So x of minus n is equal to, reverse the sequence. So then we'll get 4, 3, 2, 1. Now this is the signal. This is the time shifted signal. Now we have to find the autocorrelation. For this, first what we have to take is, take the values of x of n horizontally and x of minus n vertically. So what are the values of x of n? 1, 2, 3, 4. Then what is x of minus n? 4, 3, 2, and 1. This is the first step. So we are considering x of n and x of minus n. The next step is multiply first element of x of minus n with all elements of x of n. So take the elements of x of minus n, multiply with all the elements of x of n. So at first what we'll do, go with the multiplication, 4, 8, 12, and 16. Now, 3, 6, 9, and 12. 2, 4, 6, and 8. And then 1, 2, 3, and 4. After this, you perform the addition diagonally to get the output. So diagonally we have to perform the addition. So 4, 3, and 8, 2, 6, and 12, 1, 4, 9, and 16, 2, 6, and 12, 3, 8, and 4. Now, the next step is perform addition diagonally to get y of n. So let us perform the addition of the elements diagonally. So there is only one element, 4, 8 plus 3, 11, 12 plus 6 plus 2, 20, 16 plus 9 plus 4 plus 1, 16 plus 4, 20, 29, 30, 12 plus 6 plus 2, 18 plus 2, 20, 8 plus 3, 11, and 4. So this is how we have to find the autocorrelation. Let me repeat the steps once again. Consider a signal x of n. Find the time shifted version of the signal, that is find x of -1 by reversing the sequence, then we'll get 4, 3, 2, 1. Next is construct a table by taking the values of x of n horizontally and x of -1 vertically. After that, multiply the element of x of minus n with all the elements of x of n and write down the products. Once the table is completed, perform the addition of the elements diagonally to get the output, that is y of n. So this is we call autocorrelation. It's signal with itself. Now we'll go to MATLAB and write a program and plot this signal y of n. Now let us write the program. So to write the program, first we have to take the x value, the signal x is equal to, within the brackets. So what are the values we have taken? 1, 2, 3, and 4. And then no need of taking x of -1. We have a function called xcor to find the autocorrelation of the signal. So directly we can take y as output. Y is equal to xcor of signal with itself. So x with itself. So it performs the autocorrelation of the signal with the time shifted version of the signal that we have seen in the example, how xcor works with an example. Now just we have to use the function xcor. Now I want to plot this. I'll go with the subplot. Subplot is a function which divides the figure into m by n grid. And if you want to plot the number of graphs with m by n grid, we can use subplot option. Subplot. I'll take a 4 by 1 grid, 4, 1 grid. And the first plot I want to draw, so that is 1, that's a position. This is 4 by 1 grid. In the first position, I'm going to draw the graph. So in the first, I'll plot what is x. So for that, use stem. Stem is always used for the discrete signal. So if you want to plot the discrete data, always we have to use stem instead of plot. So x, stem of x, semicolon. You can give labels if you want. Then you give the labels. Y label as, obviously on the y label we get the amplitude of the signal. So you can write amplitude of x. So here y label as amplitude of x, because on y level we give the amplitude, and x-axis is the time, right? Time. So we are giving labels for our graph. Time. Next thing is we have to plot the output. What is the output? Autocorrelation of the signal with itself, that is y. Then again subplot with the dimension of 4 by 1 and the position of the graph is 2. Semicolon. Stem of y, semicolon. And then we have to give the labels, right? So y label, we give amplitude of y, and x label as the time again. We can copy this and paste here, and then change as amplitude of y output signal and time. So this is a program to find the correlation of the signal. So for commenting, we can use auto correlation. This is a function we have to use for the auto correlation. So this is our signal, original signal. And first we are plotting the signal. Because it is a discrete signal, we use stem signal. And this is the plot for autocorrelation. So let us run this. Once you run the program, MATLAB code, so we'll get the plots like this. So as you all know, what are the x values we have taken? We have considered as 1, 2, 3, and 4, right? And the values we got as output as when we calculate the autocorrelation, we got as 4. You can see here, the first point is 4. Next is 11. Next is 20. Next is 30. Again, we got 20. Again, we got 11. And then 4. So we got exact values. So this is how we have to find the autocorrelation of the signal using MATLAB code. So I once again repeat how to write the program. First, initialize the signal. Then use XOR function to find the autocorrelation of the signal with itself, because that's why we have considered x comma x and use for a function called XOR. Subplot. So you want to take a grid of 4 by 1 and the position of the first plot should be 1. Then put it as 1 and then plot x and give labels to the signal, x label and y label, and then plot the output. For that, we have to give the position as 2. Then stem. I have told you for discrete signal, we should not use plot function. We have to use stem function and then give the labels of the button. Go to the graph section. So we have label time and amplitude of x as input for this input signal. For output signal, we have used time and amplitude of y as the labels. And you can see the input sequences 1, 2, 3, and 4. That is, you can see here also. And the output, if you want output, you can go here and check the values we calculated. We got our 4, 11, 20, 30, 20, 11, and 4. The same sequence we got by using this XOR function. I hope you all understood how to write program. If you want to check the values, what we have calculated manually, you can click on Y. If you click on Y, you can see here the values that are calculated by the XOR function. So the same values we got 4, 11, 20, 30, 20, 11, and 4. So this is how you can check the values. You can find manually and also check in the MATLAB. Now is the cross correlation. As I told you, cross correlation is correlation of a signal with another signal with its time shifted version. So we'll consider x of n as 1, 2, 3, and 4. And y of n is another signal as 2, 3, 4, and 1. Now the output let us suppose it is h of n is x of n with the correlation of y of minus n. So this other signal should be time shifted. Now the procedure is same. First build the table with the values x of n or horizontally and taking y of minus n vertically. So to take x of n, so we have 1, 2, 3, and 4. And y of minus n as, so reverse this. So we will get as 1, 4, 3, and 2. 1, 4, 3, 2. So 1, 4, 3, and 2. So first step is to multiply. So 1, 2, 3, 4, 4, 8, 12, 16. Next 3, 6, 9, and 12. Next 2, 4, 6, and 8. No? The next part is perform addition diagonally. First draw the lines. And then perform the addition. So h of n, this is output. We get elements 1, 4 plus 2, 6, 8 plus 3 plus 3, 14. Next, 12 plus 4 plus 6 plus 2, 24. 16 plus 9 plus 4, 29. 12 plus 6, 18, and 8. And the procedure for plotting is same. Let us go to the MATLAB. Now we can draw the, we can write the program for the next one. So for that, the same we have taken as x of n. So I copy this code. X of n is 1, 2, 3, 4. Now we have considered another signal called y of y for cross correlation, right? And values we have taken as 2, 3, 4, and 1. And then this is another signal, second signal. Right? Now this is the cross correlation. Cross correlation. And we have considered h as a cross correlation output, h, x, comma, y, because we are taking the cross correlation. Now, if you want, you can plot x, y, and then go for the subplots, right? I'll just remove this. First, we'll plot 4, 1, 1 stem x. We'll consider this as same. And then we'll also plot y. Now already y is plotted. Then we'll go with the output h. So this is 4, 1, 3, the position. And this is stem of h we have to take because x is plotted, y is plotted. Now the cross correlation we have to plot h, labels or amplitude of h. And so this is, I just copied. So this is a plot. So this is the first signal, this is the second signal. This is the function to find cross correlation. The function is same, but for a cross correlation, we have to use x and y. And then it performs the cross correlation. And then plot 1 is for the x, plot 2 is for y, and procedure is same. And plot 3 is for the h. Now let us run this. Now we can see here. So X values we have taken as 1, 2, 3, and 4. Y values we have taken as 2, 3, 4, and 1. And I showed you after finding the cross correlation, the values we got are 1, right? 1, 6, 14, 24, 29, 18, and then 8. So we can also check the output in the MATLAB. For the result here also, we have taken X as 1, 2, 3, 4, and Y as 2, 3, 4, 1. And if you see here, say we calculated manually, and what we calculated, we got the same output here, 1, 6, 14, 24, 29, 18, and 8. So this is how we have to write program to find auto and cross correlation or signals in distant signal processing using MATLAB code. The function is same, that is xCor is a function to find the correlation. For auto, we'll take the correlation of a signal with itself. For cross correlation, we take correlation of a signal with another signal to check whether they resemble, there is a resemblance between them. That is the cross correlation. I hope you all understood what is the autocorrelation and cross correlation, how to find the cross and autocorrelation manually and by using the MATLAB code, and how to plot the graphs. Thank you.